Kubernetes and GKE Part 25. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain Envoy Proxy. Here's a strong way to approach it. Envoy Proxy is a high-performance, open-source edge and service proxy used to manage network traffic between services, especially in microservices and service mesh architectures like Kubernetes. It is the core data plane proxy used in systems like Istio. Core idea: Envoy acts as a smart traffic router that sits between services and controls all network communication. It handles every request going in and out of a service. Why Envoy is used in modern microservices. Services communicate heavily over the network. You need retries, routing, security, and observability. Doing this inside each application is complex. Envoy solves this by running as a proxy beside each service, managing all traffic externally from the application where Envoy runs. 1. Sidecar proxy, most common, runs alongside each application pod, intercepts all inbound or outbound traffic. 2. Edge proxy, API gateway, sits at the boundary of the cluster, handles external traffic flow. Sidecar model service. A. Envoy proxy service. B. Key capabilities of Envoy. 1. Traffic management, load balancing, round robin, least request, etc. routing based on headers, paths, or weights. Canary deployments and traffic splitting. 2. Resilience features, automatic retries, timeout, circuit breaking, fault injection, for testing failures. 3. Observability metrics, latency, error rates, traffic volume, distributed tracing, request flow across services, access logs. 4. Security, TLS termination, mutual TLS, MTLS, service identity validation. Envoy in service mesh. Envoy is the data plane in service mesh systems. In Istio, Envoy handles all traffic control plane. Istio configures Envoy. Linkerd uses its own proxy, but same concept. Why Envoy is powerful, written in C++ for high performance, extensible via filters, HTTP or TCP or gRPC, hot reload configuration, no restart needed, works in cloud native environments. Simple analogy: think of Envoy as a smart traffic controller at every intersection in a city that directs cars, checks safety, records movement, and reroutes traffic during congestion. Envoy versus traditional proxy feature. Envoy traditional proxy performance high, moderate, dynamic config yes, limited observability, built-in, minimal, cloud native yes, no. Where it is used: Istio service mesh. Primary use case: API gateways, load balancing systems, microservice communication layer. Key benefits: centralized traffic control, fine-grained routing, built-in observability, strong security features, highly scalable, interview-ready. Definition: Envoy proxy is a high-performance, cloud-native proxy used in microservices architectures to manage all inbound and outbound service traffic, providing load balancing, routing, security, MTLS, resilience features, and observability, and serving as the primary data plane component in service mesh systems like Istio. Nice. Let's continue. Question 2. What is Helm? Here's a strong way to approach it. Helm is a package manager for applications running on Kubernetes. Core idea: Helm helps you install, configure, and manage Kubernetes applications using reusable packages called charts. Think of it like app for Ubuntu, yum for Linux, npm for Node.js, backhand index, finger pointing right. But for Kubernetes apps, why Helm is used? Without Helm, you write multiple YAML files, deployment, service, config map, etc. Manual configuration is error-prone, hard to manage versions and upgrades. With Helm, everything is packaged into a single chart, easy install, upgrade, rollback, and delete. Key concepts in Helm. 1. Chart: a Helm package that contains Kubernetes manifests, templates, default configuration values. 2. Release: a running instance of a chart in a cluster. Example: my app chart installed as release 1 in dev, release 2 in prod. 3. Repository: a place where charts are stored and shared, like Docker Hub for images. How Helm works: 1. You define a Helm chart. 2. You install it using Helm CLI. 3. Helm renders Kubernetes YAML templates. 4. Kubernetes API server deploys resources. Example: workflow: install an app, Helm install my app my chart, or upgrade an app, Helm upgrade my app my chart, or rollback an app, Helm rollback my app. 1. Helm chart structure: my chart or chart YAML metadata values, YAML default configs, templates or Kubernetes YAML templates. Example use case: instead of writing Deployment YAML service YAML config map YAML backhand index finger pointing right. You use one Helm chart and just change values. YAML Y Helm is powerful reusability. Same chart for dev or prod. Version control of deployments, easy upgrades and rollbacks, simplifies complex Kubernetes apps. Helm versus raw Kubernetes YAML feature. Helm raw YAML reusability, high-low upgrades, easy manual rollback, built-in manual complexity. Lower higher simple analogy, think of Kubernetes like cooking. YAML files equals individual raw recipes. Helm equals ready-made cookbook with customizable ingredients. Key benefits: simplifies deployments, manages application lifecycle, supports templating and customization, enables DevOps automation. Interview ready definition: Helm is a package manager for Kubernetes that allows users to define, install, upgrade, and manage applications using reusable charts, enabling simplified deployment, version control, and lifecycle management of complex Kubernetes applications. Great. Moving on. Question 3. Explain Helm charts. Here's a strong way to approach it. A Helm chart is a packaged collection of Kubernetes resources that defines, configures, and deploys an application in Kubernetes using Helm. Core idea: a Helm chart is a reusable blueprint for deploying an application on Kubernetes. It bundles all Kubernetes manifests into a single, configurable package. Why Helm charts are used without Helm charts? You manage multiple YAML files manually. Configurations are repeated across environments. Deployments are harder to maintain with Helm charts. Everything is packaged in one structure. You can reuse, version, and customize deployments easily. What a Helm chart contains: a typical chart has 1. Chart YAML metadata about the chart: name, version, description. 2. Values YAML default configuration values used to customize deployments without changing templates. 3. Templates or Kubernetes YAML templates: deployment, service, config map, etc. 4. Charts or dependencies, other charts. Example: Helm chart structure, my app chart or chart. YAML values, YAML templates or deployment, YAML service, YAML config map. YAML charts or how Helm charts work. 1. You install a chart using Helm CLI. 2. Helm reads values YAML. 3. It replaces placeholders and templates. 4. Generates final Kubernetes YAML. 5. Sends it to Kubernetes API server for deployment. Example: values YAML replica count. 2. Image, repository, ginks tag. Latest example: template, deployment API version, apps or v1 kind, deployment metadata, name.release name, app spec, replicas.values replica count, template. The exact commands and code are in the written question bank. Alright, next question. Question 4. What are CRDs? Here's a strong way to approach it. CRDs, custom resource definitions in Kubernetes, are a way to extend Kubernetes by creating your own custom resource types beyond the built-in ones like pods, services, and deployments. Core idea: a CRD lets you define new APIs in Kubernetes as if they were native objects. In simple terms, Kubernetes already has resources like pod, service. With CRD, you can create your own, like database, backup, Kafka cluster, etc. Why CRDs are used: they help you extend Kubernetes functionality, model real-world applications as Kubernetes objects, build platform-level abstractions, enable operators, automation controllers. How CRDs work: 1. You define a custom resource definition. 2. Kubernetes registers a new API type. 3. You create custom resources of that type. 4. A controller or operator manages them. Example: CRD definition: API version, AP extensions, K8SIO or v1 kind. Custom resource definition: metadata, name, databases, mycompany.com spec, group, mycompany.com names. The exact commands and code are in the written question bank. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.